Hello everyone, my name is Ian and I'm back again, doing this again, reading stories. These are all accurate stories, but they're from over 50 years ago. Um, I think information these days is very sort of embellished overboard, and people go bananas with putting stuff on which isn't quite right. But this stuff, say you go back in history, you want to find the truth, you have to look, you see. So I found a book of truths from the 70s. So I'm going to read three stories today, two or three anyway, so I'll see where I go. Um, they're all about water anyway. So this one's called The Ancient But Inexhaustible Cycle of Water. So now I'll begin. Earth retains all the water ever created, an estimated 326 million cubic miles of it. Water responds to a variety of powerful forces: the heat of the sun, the pull of Earth's gravity, and the tidal forces of the sun and the moon. The result is a natural cycle in which water has been used, purified, and reused for 3,000 million years. The accepted theory of how water was formed is that a chemical reaction took place between hydrogen and oxygen took place as the Earth cooled. This produced H2O, 2 parts hydrogen to 1 part of oxygen. As gases that formed, the Earth cooled and became liquid particles. A dense cloud blanketed the Earth. When the temperature dropped, the clouds shed their water, a downpour that lasted for 60,000 years, filling the oceans and the lower land basins that were formed when the molten crust hardened. Although water is still produced by man-made and natural process, the levels of the oceans and the amount of water on the earth remain relatively constant. The amount of man-made water is relatively small, and water produced during the formation of a volcanic rock is balanced by water lost in the weathering of minerals and when it is trapped by sediments. About 97.2% of the Earth's water lies in oceans and 2.15% is held in ice caps and in the ancient glaciers of the high mountain zones. The remainder is spread over an area ranging from 3 miles below the Earth's surface to 7 miles up in the atmosphere. Rivers and streams account for only 0.0001% or 300 cubic miles. Other surface water totals to some 55,000 cubic miles and is divided between inland seas and fresh saltwater lakes. In addition, the Earth has a reserve supply of some 200,000 cubic miles of water below the surface. That in the upper layer, called the aeration zone, clings to soil and rock, is absorbed by plants or returns to the air through evaporation. Deep lying water in what is called the saturation zone feeds swamps, rivers, lakes and wells. The Sahara Desert has an underground reservoir of some 150,000 cubic miles. The atmosphere holds around 3,100 cubic miles of water, enough to cover the earth with 1 inch of rain if it fell at one time. This atmospheric water falls as rain is replaced by evaporation every 12 days or so. Most rain falls in the sea or runs into rivers. About 1/6 soaks into the earth to nourish growth. Water has many unique properties, as skin forms for example, where water meets other materials. Water molecules are more attracted to each other than to other substances, and consequently they squeeze together forming a dense layer. This phenomenon is called surface tension. The same attraction of molecules also gives water its ability to climb uphill. Capillary reaction, as it is called, causes water to move upwards through the ground to the roots of plants and through stems and leaves. Water absorbs more heat than almost any other common substance without a considerable rise in temperature. When a kettle of water is put on to boil, it is subjected to a temperature that would cause many substances to melt or burst into flames, but the water soaks up the heat until a temperature of 100 degrees centigrade. which is 212 degrees Fahrenheit, is reached. Then the water boils and steam bubbles bursting through the surface tension. Another of water's unique qualities is that it floats when frozen, and although it expands at freezing point, it becomes less dense. The force of water expanding as ice in the earth cracks rocks, helping to produce soil. In Arctic regions, huge ice floes form and cover the surface of lakes and oceans with a protective insulating blanket, preventing further freezing. This helps life to go on under the blanket of ice. There is no life, for instance, on the 16-foot thick pack ice of the North Pole, but it teems in the ocean beneath. If ice did not float, it would build up gradually from all the ocean beds and eventually cover our planet in a solid glacier-like mass. Life as we know it then would be unable to survive. That's the first story. The second one about water is this one. It's about the oceans and how important they are. So I'll read this one now. I'll start now. Water covers 70% of the Earth's surface, and in the ocean deeps is a dark, sunless world of spectacular canyons, great plains and mountain ranges. Much of the ocean floors are plains that stretch for hundreds of miles at an average depth of 13,000 feet. Rising from these flat areas called abyssal plains are mid-ocean ridges which girdle the globe, only occasionally breaking the surface to form islands. The Mid-Atlantic Ridge, reaching 10,000 miles from Iceland to the Antarctic, is by far the world's longest mountain range. Its highest peaks are the Ascension Islands, the Azores and Iceland. From the ocean floor in the mid-Pacific rises the world's highest mountain, the Hawaiian volcano Mauna Kea. It is 31,000 foot from base to peak, overtopping Everest by nearly 2,000 feet, but only the top 13,823 feet show above the surface. Sunlight can penetrate to a depth of only 800 feet, and many of the creatures that live in the perpetual midnight of the depths have evolved their own luminous lighting system. Their survival depends ultimately on a constant drizzle of food reaching the ocean floor, waste matter from the levels above. Trenches split the floor of some oceans. The deepest known as is the Challenger Deep in the Marianas Trench, discovered by the British survey ship Challenger in 1873 off the island of Guam in the Pacific. It is 7 miles deep, and if Everest, 29,028 feet high, were placed in it, there would be a mile of water just above the summit. Just as mountains are barriers to movement on land, so the ranges of the sea act as barriers to ocean dwellers, or undersea creatures have to keep to the levels for which they are adapted. At 13,000 feet there is a pressure of nearly 3 tons to the square foot. Most of the great land masses are skirted by continental shelves which slope gradually for up to 200 miles before plunging steeply into the deep. Some parts of a shelf are split by vast canyons. The Hudson Canyon off New York is 150 miles long and 16,500 foot deep. These canyons may be caused by avalanches of mud and water called turbidity currents that roll down the shelves to the ocean floor. The oceans absorb heat from the sun and spread it across the world in the form of vast currents. These are driven by the winds, which are themselves created by the effect of the sun's heat. All major currents move in a circular path called a gyre, caused by the Earth's rotation. One of the most powerful currents is the Gulf Stream, which when it leaves the Caribbean is 50 miles wide and up to 1,500 foot deep. This warm current broadens and flows across the Atlantic at a speed of around 4 knots. In the North Atlantic, the flow divides, part flowing north past Scotland, while the other sweeps south. The daily rise and fall of tides is caused by the gravitational pull of the moon and sun. The effect of each pull causes, in effect, a bulge in the ocean. When the sun and moon are pulling on the same side of the earth, large tides, the spring tides, occur. Neap tides, the smallest, happen when the sun and moon pull at right angles. The largest tide occur when the sea runs into bottlenecks, as in the Bay of Fundy on America's east coast. Waves are whipped up far out to sea by wind. They move across the water, which merely rises and falls as the energy swell passes. In shallower water, the energy is concentrated and the wave rears up and breaks. Waves in mid-ocean often reach a height of 40 feet. In 1933, the American ship USS Ramapo survived a 112-foot wave, the highest recorded. The level from which altitudes are measured is called sea level. This is an average of the ocean levels, for in reality the sea is not level at all. If, for example, the Pacific Ocean were suddenly frozen in a calm without a ripple on its surface, there would be a plateau and depressions in the water with a difference of much as 60 feet. This is caused by differences of atmospheric pressure and by the slurping effect of the tides. That's the second one. This one's called When the Sea Trembles, and it's about earthquake. When it's called the killer wave, it's about tsunamis, basically tsunamis. So what I'll do is I'll do this. On April the 1st, 1946, an earthquake. If you want to subscribe. I won't keep you. I'll read the story. I'll start again now. On April the 1st, 1946, an earthquake shook the abyssal plain deep beneath the Pacific Ocean. The wave it generated travelled the 2,250 miles to Hawaii in 4 hours and 34 minutes, an average speed of 490 miles per hour. When it struck the town of Hilo, the wave was more than 45 foot high. It killed 173 people, injured hundreds more, and caused £50 million worth of damage. The tidal wave was a tsunami caused by the movement of the seabed in the earthquake. Tsunamis are the most terrifying waves of all, hurtling silently across the ocean to crash onto the nearest shore. Ancient monuments along the coast of Japan carry the inscription, "When you feel an earthquake, expect a tsunami," a piece of advice which reflects Japan's long history of tsunami disasters. The word tsunami is Japanese and was adopted by scientists of other countries to replace the misleading term tidal wave. Since tsunamis are not tidal at all, the wave spreads from the centre of the disturbance, like the ripples from a pebble tossed into a pond, but the waves generated are so long and in deep water the swell is so slight that ships do not notice them. The energy stored in the tsunami is only about 1/100th of the total energy of the earthquake, but it can equal the power of a multi-megaton nuclear weapon. As the tsunami approaches the shore and gets into shallower water, its energy becomes more concentrated and the wave height increases. Usually the wave is preceded by a trough which sucks out water along the shore, beating ships like an abnormally low tide. The effects of a tsunami are nearly always terrifying and sometimes extraordinary. An oceanographer caught in a Hawaii tsunami of 1946 reported that one house was plucked from its foundations, carried hundreds of yards and set down again so gently that the breakfast the occupants were cooking was not spilt. After the 1946 disaster, a tsunami warning system was set up in the Pacific. The ocean most affected seismographic stations distributed across the Pacific notify tidal stations whenever an earthquake is detected. That was 3 stories about water. I've got one more. Go on, I'll tell you what. I'll do one more, and I hope you enjoy it. Please like and subscribe if you like these stories that I read. I'll do one more. This one's called "The Mediterranean Was a Desert, How the Seabed Revealed Its Secret." 6 million years ago, the Mediterranean Sea dried up, leaving a barren desert lying 10,000 feet below the level of the Atlantic. Then the ocean burst through the Straits of Gibraltar and its water cascaded into the Mediterranean, basin in the most spectacular waterfall the earth has ever seen. It was like turning on a gigantic tap to fill a bath 10,000 feet deep and around 2,000 miles long. 10,000 cubic miles of water poured through the gap in a torrent 1,000 times greater than Niagara. Even so, it took more than 100 years to fill the basin up to the level we know today, flooding vast areas and leaving only mountain peaks above the water to form islands such as Malta and Sardinia. The evidence for this story has come from geological drilling into the bottom of the Mediterranean carried from the US research ship Glomar Challenger. In 1970, the ship, which was amassing scientific data about the theory of how the continents have drifted apart, sailed through the Straits of Gibraltar and began to drill into the soft sediments lying into the seabed, lying in a seabed 6,000 foot below. 600 feet through the sediment, its crew of scientists found a layer of gravel unusual for ocean beds. More holes were drilled and they revealed even more extraordinary findings. The types of rock that lay below the sediments were what geologists call evaporites. They are only found in places where seas have dried up. The scientists were at first unable to believe that the Mediterranean had once been a desert, yet it was so impossible. The climate of the region is dry, and even today the sun sucks up water from the surface of the Mediterranean faster than rain and rivers can fill it. Evaporation is at the rate of 1,000 cubic miles of water every year, and only the flow from the Atlantic keeps the basin full. Suppose that at some time in the past the strait had closed, isolating the Mediterranean from the Atlantic. It would have taken only 1,000 years to dry up the Mediterranean completely, turning it into a deep parched canyon, something like Death Valley in California. There was one final piece of evidence which clinched the argument. 70 years ago, a deep gorge was discovered in southern France, cut into granite and lying hidden beneath millions of years of deposits. It looked like the gorge of an ancient river, but it lay hundreds of feet below the level of the Mediterranean. Although the scientists on board the Glomar Challenger did not know it at the time, an exactly similar gorge lay at the other end of the Mediterranean under the river Nile. Russian scientists had been mystified by it while building the Aswan Dam. Only one explanation is possible. The gorges must have been cut by rivers flowing into the Mediterranean basin when the level of the sea was much lower than it is today. The rivers flowing across what is now the bottom of the ocean cut canyons which have also been found in the ocean bed. So the Mediterranean was once a sea, then a deep hot canyon, dotted with isolated salt lakes. Then after 1.5 million years it became a sea again, as the dam burst at the straits and water came crashing in from the Atlantic. Right, I hope you like them stories today. I'll finish now. So if you like listening to these type of things, will you please subscribe to my channel and press the like button if you don't mind. So I'll leave this for today and I'll do one in the next couple of days. Thank you very much. Bye.